welcome to Two Projects. In this video, we are going to explain the project Telugu Numericals Detection using Yolo. So, the project's main goal is to develop a system that can accurately find and highlight Telugu numerical characters in images or videos. So, this ability is crucial for tasks like sorting documents, reading text from images, that is OCR, and automatically organizing content. Since Telugu has its unique script and way of writing numbers, particularly used in India, this project becomes important for converting documents into digital format and simplifying data entry processes specifically for Telugu speaking people. So it emphasizes the need to improve technology that understands and supports languages like Telugu to better serve these communities. But traditional methods for detecting numerical characters typically involve manually designing features and creating rules based algorithms. These approaches are often time consuming and may not perform well on datasets with diverse characteristics. So, there comes computer vision and deep learning technologies. So, computer vision with deep learning techniques, by integrating them, we can adopt a more effective and scalable approach to numerical detection. Deep learning models such as Yolo, that is, you only look once, have the capability to autonomously learn distinctive features, that is, complex features from data, and accurately pinpoint objects within images or videos. So, we are using both computer vision and deep learning, specifically Yolo, in this project to detect Telugu numericals. And now we'll discuss about the workflow. So we have used Telugu numerical images to train the deep learning models. Before training the models, we will pre-process the images. So pre-processing the numerical data involves getting it ready for training detection algorithms. So first we'll make sure all the images are in a format that the model can easily understand. Then we resize the images to same size so the algorithm can work with them efficiently. We also adjust the colors to make sure the algorithm can see them clearly. Additionally, we add more variety to the dataset by making slight changes to the images using data augmentation techniques like flipping or rotating them. So this improves generalizability of the models. Finally, we organize information about where numericals are located in the images so that the algorithm knows what to look for. So, this pre processing makes the dataset consistent and diverse, helping the algorithm learn better and detect numericals accurately in different situations. So, this is what happens in this project. Now we'll see the objective of the project. So the project's main goal is to build a smart system that can accurately spot Telugu numerical characters using cutting edge deep learning techniques. So by achieving this aim, the project aims to improve tasks like analyzing documents, recognizing text, and understanding Telugu language better. Ultimately, it seeks to make digitizing and automating tasks easier for Telugu speaking communities, contributing to their technological progress. So now we'll see the software and hardware requirements. So hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requiremends to execute this project are: application needed is Anaconda, primary language required is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll discuss about the algorithms used in brief. So YOLO, that is you only look once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, Yolo processes the image just once, making it extremely fast. So it predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non maximum suppression. So this results in a final list of detected objects along with their bounding boxes and probabilities. And these are different architectures in YOLO. There are many more. We are building these models in this project. So YOLO V5, it is known for its balanced performance between accuracy and speed. So this version relies on a backbone network called CSP Darknet 53. It utilizes focus modules for downsampling and path aggregation network PAN for feature fusion, enhancing object detection across different scales. Coming to YOLO V6, this model introduces a key difference by using Efficient Net L2 as its backbone network. Compared to Efficient Net used in YOLO V5, Efficient Net is known for its efficiency with fewer parameters. And YOLO V6 also employs a novel dense anchor box generation method to improve object detection accuracy. And YOLO V7 uses a modified version of the Swin transformer architecture as its backbone. So, this architecture leverages self attention mechanisms, leading to better feature extraction compared to convolutional neural networks used in prior versions. Now, coming to YOLO V8, it is the latest version focused on facilitating performance comparisons with older YOLO models. So YOLO V8 also introduces a unique loss function and an anchor-free detection head, which are technical improvements to the overall detection process. So after comparing all these models with different metrics like map, precision, and recall, we have observed that YOLO V5 has outperformed all other models in all the performance metrics. So we will be deploying, so we have deployed YOLO V5 into Flask. Now we'll see the execution. Before executing the project, first we need to open the code folder which contains the project source code files. So this is the code folder. This is sample folder in which I have images, these Telugu numerical images on which we'll make the detections. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information. So this file will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now we'll see the dataset used. So I'm opening the YOLO V5 folder. So here I have two folders, test and train. I'm opening train folder. I have two subfolder, images and labels. So in images folder, I have these Telugu numerical images of numericals 0 to 9. And I have 2395 images in total. So using these images, we will train the deep learning models. And this is labels folder in which I have files containing annotations or labels for objects in the corresponding images. So each label file corresponds to an image file in the images folder, providing details about the object's locations and classes within the image. So this annotation file corresponds to this image. Similarly, this annotation file corresponds to this image. So in the same way, each annotation file corresponds to an image in the images folder. So these label files often follow the Yolo format where each line represents a detected object. So this is the line I'm talking about. So each line specifies the object's class, index. 0 means 0, 1 is for numerical 1, 2 is for numeric 2 in Telugu numericals, 3 is for numerical 3. So followed by its bounding box coordinates normalized to the image dimensions. So these are the bounding box coordinates: x limit, y limit, width and height. So I have the same object's class index followed by its bounding box coordinates in all other annotation files also. So on these files, the annotation files and image files, we will train the deep learning models. So I have images and labels folder in test folder also. On these files, annotation files and image files, we will evaluate the model's performance. So in the same way, Yolo V6, V7, V8 also contains these images and label files. So each folder contains the same images, but they are annotated differently. They will have different annotation files because each Yolo version requires its own specific type of image annotations for training and testing the models effectively. So having separate folders helps keep the dataset organized and ensures that each YOLO version receives the correct annotations to function properly. So this is all about the dataset. So now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anaconda prompt. Now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, local host, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a register link, click on it. So if you are new users, we have to register ourselves first. Fill in all these details and click on register button to sign up. And if we already have account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Now here we have to provide a credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the detection page. So now we have to upload any Telugu numerical image here and the application will detect and classify the Telugu numerical from the image. Click on choose file button. So from sample images folder where I have these test cases, I'm selecting the first image and click on open. The image has been loaded. Now click on upload button. So we can see the application has detected the Telugu numerical and it has drawn a bounding box around the detected Telugu numerical and we can see it has classified this Telugu numerical as 0. And we can also see a probability score here that is 0.84, which tells us the confidence level, how confident the application is about the classification and detection. Click on back, we'll try again. Click on choose file button. This time I'm selecting this image and click on open. The image has been loaded. Now click on upload button. So we can see the application has drawn a bounding box around the detected Telugu numerical, it has classified this Telugu numerical as 4. And we can see the probability score here. We'll try with another image. Click on choose file button. This time I'll upload this one. The application has detected the Telugu numerical. It has drawn a bounding box around the detected numerical. And we can see it has classified this numerical as 3. And we can see the probability score. Now I'll try with this one. So we can see the application has detected the Telugu numerical. We can see the bounding box drawn. And this time the classification is 5. And it is 0.90, 90% confident about this detection and classification. This time we'll try with this image. Click on open. The image has been loaded. Now click on upload button. So this time the classification is 8. The application has detected the Telugu numerical. It has drawn a bounding box and classified the numerical as 8. And it is 87% confident about this detection and classification. So this time we'll try with this image. So this image has been, this numerical has been classified as 2. So we can see the bounding box drawn around the detected numerical. So similarly, we can upload any Telugu numerical image and can get the detections and classifications. We'll try with this image. Click on open. The image has been loaded. Now click on upload button. So we can see this time the detection, the classification is 5. We can see the detection has been made. We can see the bounding box drawn around the Telugu numerical detected. And the application is 78% confident about this detection and classification. We'll try with some more images. I'll upload this one. The image has been loaded. Click on upload button. So this Telugu numerical has been classified as 1. We can see the bounding box drawn around the detected numerical. And this time the application is 75% confident about the detection and classification. So similarly, we can upload any Telugu numerical image and can get the detections. So this Telugu numerical has been classified as 8. We can see the bounding box drawn around the detected Telugu numerical. And this time the application is 86% confident. Now we'll see the visualizations made. So here we can see a graph link, click on it. Here we can view all the visualizations of the algorithms built. So this is precision recall graph of Yolo V5. This is F1 scores graph of Yolo V5. This is confusion matrix graph. This is precision scores comparison graph, a horizontal bar graph. In this graph on x-axis, I have precision scores and on y-axis, I have algorithm names. So this is recall scores comparison graph. Similarly, this is MAP scores comparison graph. So from all these graphs, we can say that YOLO V5 is performing well when compared to all other models. Now click on logout. So we have seen detection and classification of Telugu numerical characters using advanced deep learning techniques. So using this, we can enhance document analysis, OCR, and language processing, paving the way for automation and digitization in Telugu speaking communities.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.